Hi everyone, this is Sujal here. Today we will be solving problem number 623 of LeetCode, that is add one row to tree. This problem is marked medium by LeetCode, but I would say that this is no harder than an easy one because in this question you just have to figure out the base case, the smallest problem that we can have, and then just we have to iterate over it using recursion. So this is a classic example of a recursive problem. So let's go through it. One thing is that I won't be reading up the description today as it will just confuse you over. I would suggest that you read it yourself. I will just go through the examples and show you how and what is the problem looking like. Okay, coming to the examples, this is the first one. We are treating the first row as depth equal to 1. So this will be depth equal to 1, depth equal to 2, depth equal to 3, and so on. For this one, 1, 2, 3, 4. Okay, so what we have is a tree like this, and what we have to insert is a row of nodes containing the value that is 1 in this case, and it should be inserted at what position? It should be inserted at depth equal to 2. So in this case, depth equal to 2 is this one. So we have to shift this part below and then insert our row here. If you have read the description correctly as I have instructed you earlier, you just have to go back to its parent, the last node, and then our new nodes will be its child like this 4 1 1. These are the new ones, and the left child of the left new node will be our old child, old left child of our old parent. Okay, so here the left child of 4 was 2. So in this case, the left child of 4 is 1, and the left child of 1 will be 2, and the rest will remain as it is. Similarly, here the right child of 4 is 6, and here you have 1. So the right child of 1, the right one is will be going to be 6, and the rest will remain same. Coming to the second example, here also you will see that we have to insert at depth equal to 3. Here what it is 1 2 3, this part. So this will go below and some nodes will come here. So what is the parent in this case? 2. So 2 will have the new nodes, that is 1, left one, and the right one. Now the left one will have its left child as 3 because here 2 have the left child as 3. So it will come like this. Similarly, for the right one, we have its right child as 1 because see over here, the right child of 2, the old parent, was 1. So we have to get it something like this. I will show you one more example so it will be clear with it, I hope. Let's see. Before moving to our last example, I would like to start with the coding part. Go and read the description and carefully read the last point, where it is mentioned that what happens when depth equal to 1. So if depth equal to 1, we will create a new node, just a new node, not two, just a single new node like this with the value of course, and then its left child will be our root, and the new node that we just created will be our new root. Why? Because look, if you are willing to insert at depth equal to 1, you have to push down the root below, and there is only one root. See, there are uh, no two childs or something. It doesn't have any parent. You see, in other cases, in example 1 and in example 2, we saw that there was an old parent and then we synced it all over. But in this case, we only have a single node and rest are just below. So in this case, we will just create a new node, make it the root, and then have its left child as the as the old root. Here, the one we get here will be our left child. So what we will do otherwise we will just go recursively along with a function add row. Let's say we will pass root, value, and depth as it is, and in last we will return our root. See, we are updating the root here just in case this part gets activated. Otherwise, this will handle everything else correctly. So now we have to implement this method. For this, okay, we have our method created over here. For this, we have to think about the base cases. So what could be the like uh, cases in which we have to terminate? So the first thing that must come to your mind is if root equal to null, we just have to return. Nothing to do over here. Okay. Next, what if you have read the description correctly, you will instantly hit this. I will write if depth equal to 2, we will do our stuff here. So why depth equal to 2? Depth equal to 2 will be uh, there when we are at the parent of the new nodes that we are going to have. Okay, so we are talking about the root, that old parent or the one we are referring in earlier. So what we have to do here, we have to create two child cells, two children here. Okay, whatever. So we'll call it left new node, and we will have the value. Okay, I will just duplicate it, and instead of left I will right new node. Okay, so here you have to be careful. We have to make the left child of left node, one second, left child of the left node as left child of the root. Similarly, we have to make the right child of the right new node as the right child of the old root. Okay, after this we have to um, make the left child of the root as the new node, and the right child as the right new node. Okay, and this will be done. But what if we have not got to the depth, that parent that we are looking for? We'll just keep searching. For this, we will go recursively. We will call the function add row recursively. So the root will be the same. No, the root will be like, first of all, we will call root dot left. Like we have checked the root. Okay, we have not, it is not the parent we are looking for. We will go on the left hand side as well as the right hand side. So this line is for the left hand side, root dot left. Okay, we will pass the same value, of course, and this time the depth will be depth minus 1 because we are going one row below each time we are calling this. Okay, similarly we can just duplicate it, and instead of root dot left, we have to say root dot right to check the right portion, the right part of the subtree. Okay, after this we should be done. Let's see if this works. I will explain you with the example as well, but let's see if this much. Just one second. It passes our normal test cases. Yes, it does. It has been accepted with 100% 100 percentile actually. So yeah, that works. Moving on to the last example, just in case if someone is unable to understand even till now, so here it is. We have to add a value 0 at depth equal to 3. So take a look here. This is depth equal to 1. Okay. What we have here? Just 5. At depth equal to 2, we have 8 and 6. At depth equal to 3, we have 3, 7 and 2. Similarly, these are here at depth equal to 4, whatever. And we have to, what we have to put 0 at depth equal to 3. So basically, this part will go downwards and we have our new nodes over here. So we will start with from here. We will check if depth equal to 2. No, depth equal to 3 for now is 3 for now. We will now move left due to the recursion 2 dot left that we did here there. So now our depth equal to 2. Yes, this is the our parent that we were looking for. We will instantly insert our zeros over here like this and then move the rest of the subtree downwards. Similarly over here, when you call that recursive method with root dot right, it will come over here with depth equal to 2 because this is decrementing one after other. So we will find the second parent that we were looking for and insert our zeros over here just like this 6 0 0, and this portion will remain same and to the left and will remain at the left of the our left 0. Why? Because it was like that initially, so we won't be changing that. I hope with this the problem is clear now. If you still have any doubts, you may ask in the comment section. No worries. um, Thank you for watching till far. Thank you very much. Bye.